slide इसमें लगी हुई है। A very warm welcome to all of you, and from Bureau of Indian Standards. Probably this is the first time that we would be addressing here. I would give a brief about BIS, and I would restrict my presentation to only what would be concerning the people in HBTU, probably the students. So if you see B47, it's a very old institution, and at that time it was known as the Indian Standards Institution, and then later on by an act of the Parliament in 1986, it was renamed as Bureau of Indian Standards with certain powers which were not available to us earlier. And then in 2016, it has again, 16 Act came into force for some of the things which we were not covered earlier. For example, hallmarking, which BIS was doing, was not covered under the earlier Act. So in order to make those changes, and particularly one major change that happened was that BIS was given the position of the national standards body of the country, and was made responsible for the development of the activities of standardization, conformity assessment, as well as quality assurance for goods, services, process and systems as well. We do a lot of activities. We are into standard formulation, which means we develop the national standards for this country. We are also into certification, where we do the product certification as well as the system certification. We do gold hallmarking, we do sample testing through our laboratories, which we have. We have around 8 laboratories of our own, and more than 200 laboratories which we have recognized from the private sector for testing of samples drawn by BIS. We do carry out a lot of activities related to consumer protection. For example, the products which are available to the consumers must be meeting certain criteria, and for that we carry out a lot of consumer related activities. As well as we are a former or I would say a founder member of the International Organization for Standardization, ISO, as well as IEC, and we participate on behalf of India in the ISO and IEC International Standardization. So we work through a system of committees. All the committees have representation from all the stakeholders, which includes industries, which includes consumer organizations, which includes laboratories, which includes R&D organizations, which also includes the regulator for that product. And as on date, we have 17 division councils for various areas such as civil, electrical, mechanical, chemical, petrochemicals, food, etc. And this work is being done by more than 400 committees, and more than 19,000 experts are associated with BIS in this activity of standard formulation. So we have faced certain challenges in the recent years, and we have done some process reforms in the activities. What we have done is we tried to make all these activities more efficient and smart by doing certain changes and carrying out certain process reforms. I would not go into those details right now, probably because the time would not permit it. But I would specifically come to the area where HBTU can contribute to the national standardization. Now this will be applicable to both the students at HBTU as well as the faculty of HBTU. In recent years, we have decided that the standard formulation that we do, or the national standards that we formulate, should be based on some research, or I will say empirical research, which needs to be carried out. So what we have done is we have started a practice of instituting small R&D projects of up to 10 lakh rupees, which may be completed within a period of 4 to 6 months, and which would involve mostly, I would say, literature survey, as well as going and visiting the industries which are manufacturing those products, getting information on those as to what are the changes in the manufacturing processes which would have happened, or the testing processes which would have happened. So this R&D projects that we are starting, or we have started as of now, more than 250 projects have already been allotted in the last 6 months, is open only to 2 categories of people. One is the committee members of BIS, the other is the MOU institutes or we have made MOUs with 92 technical institutes in the country, which includes all IITs and ITs and major institutes. And third is the CSIR laboratories which are there. So HBTU can take up this as an organization which can form an MOU with BIS and then can take part in this. Plus, we do offer internship to students who are in their third year for a 2-month summer internship on various projects where the students of HBTU previously have also participated and can participate. These two areas particularly we feel that can be used as an opportunity. Plus at the same time, our purpose of having the MOU with the academic institutes in the country, if you go on our website, you will be able to see all those 92 institutes that we have an MOU, was to utilize the expertise which is available with these academic institutes in various areas, particularly the lecturers, the professors, that they can become members of our committees and contribute to the national standardization, because they have certain expertise which normally the committee would not be aware of. At the same time, there is a possibility of having a young professor of less than 37 years of age also as a young professional in the committee. And there is a scheme where we sponsor these young professionals to participate in international standardization also. So that is a very good opportunity for people who are young assistant professors to become a member of our committee and get exposed to international standardization, fund their international travel for attending the ISO meetings also. So people with expertise in those areas, you can go to our website and see if there is any area which is of particular interest. We have come here because I particularly deal with the chemical department, and we can tell that there are two particular committees which would be of interest to this institute. One is the soaps and detergents committee that we have, where most of the standards related to soaps and detergents are there. And the other would probably be the oil seeds committee, which would be with our food and agriculture department. So that would be an area where, probably if HBTU has leather technology, specifically on leather, India also holds the ISO Secretariat for leather, which is with India. So that is also an area where people can contribute. This is just the details of the projects that we have already launched. You can see that each department, ETD stands for electrical and CHD stands for chemical, the number of projects that each department has already given. We do a lot of expert engagements, and recently what we have done is, in order to utilize the pool of experts that is available in the country, we have decided that for each, since the time is short, I would not go into the details, but ISO works in the system of vote casting. Each country has one vote to be casted. India also has one vote, and the documents are developed through a balloting system. Ballots are launched. So what we have done is, in recent times, we have decided that for each ballot that we receive for voting, we will involve 2 experts from India who would be attached to that ballot, and they would be entrusted with the task of providing the India's viewpoint position on that subject throughout the development of that subject, till from the starting new proposal stage to the final when the document is printed. That expert would be attached to that document, and all the work related to that document would be done by that expert, which would involve attending the meetings of that committee, which makes that document, whether it is a virtual meeting or it is a physical meeting, that expert would be involved, required to attend the meetings, and all those expenses would be borne by BIS in that case. So that is an area we would request that people who are interested in this, please go to our website. There is a list of all open ballots that is available. We also are advertising the same thing on our academic dashboard, that these are the subjects on which India is casting their ballot. If you have any expertise on this subject and you want to be involved with the standardization in this subject, please write to us, and we can nominate you as an expert for that subject and add you into the ISO Global Directory, and you can participate. Because recently we have decided that as India, we need to increase more and more of our global footprint, in the sense that instead of just being standard takers, we should move from the position of standard takers to standard makers. And Indian standards should be promoted at the international level. We have proposed a lot of standards at the international level. If you see, we are holding 11 secretariats of ISO with us of applying for more secretariats. This, I think so, is not of relation to this. This is the details of the MOU that I'll just finish the last slide, sir. These are the details of the MOU that we have done with various institutes. These are the points on which collaboration is happening. So if HBTU feels it is convenient to them, I think so you should approach BIS for having an MOU, and that would open up a lot of opportunities for HBTU as a organization, as well as for the students and faculties of this department. Thank you.
Thank you. Now I request Mr. YP Singh, Dr. YP Singh, CEO Calibration Fair Labs Private Limited, to start his talk, and may I request him to kindly take only 10 minutes, please.
Thank you, Mr. Chairman, and ladies and gentlemen. So before going on my introduction, let me thank the organizers and Fair Labs for giving me this opportunity to talk about the calibration, a critical parameter in the food industry for quality standards. Well, sorry for the disturbance. As I told that the topic which I am going to interact, a critical element for maintaining quality standards in food and oil industry. So calibration is very, very important parameter. In the morning, Dr. Raja emphasized that when sustainability of the food, quality in the food is there, so maintaining the quality, maintaining the sustainability, the quality is very, very important parameter. And I will just elaborate this parameter in little detail. I will discuss about the quality infrastructure and its importance, metrology, international system of units, International Bureau of Weights and Measures, calibrations, its implications, and why calibration is critical in food and oil industry, importance of calibration in gas chromatography, and how does metrology support the trade. You see, the quality infrastructure is a base parameter here, which is a system contributing to governmental policy objectives in areas including industrial development, trade competitiveness in global markets, efficient use of natural and human resources for food, safety, health, etc., etc. So this system comprising the organization, both public as well as government, together with policies, relevant, legal, and regulatory framework and practices needed to support and enhance the quality, safety, environment, sound, and processes. So basically, quality structure, quality infrastructure is also known as standard and conformance infrastructure. Why quality infrastructure is important? You can see the quality infrastructure is it impacts our daily lives, such as the safety of our food, accuracy of our alarm clocks in the morning, household, gas or electricity meters, safety measures in factories, complex technologies, and industrial processes that drive economic growth and productivity and innovation of a country. Every day, commercial transactions and international trade could not take place without support of quality infrastructure. Now, quality infrastructure basically has the components which are in terms of 4 pillars: metrology, accreditation, certifications. From international area, the organizations which are responsible, for example, CIPM, OIML, IAF, ISO, ICE, etc., etc. So these are the organizations which are supporting the quality infrastructure internationally. And in our country, these 4 pillars are taken care by the National Physical Laboratory for the metrology, NABL for accreditation, BIS for documentary standards, and certification bodies like QCI, NABL, NABCB, BIS, CPCB, etc. So what is actually the metrology? Metrology is basically the science of measurement, where the definition is given by the international departments of weights and measures. And it has the definition embracing with both experiment So the definition given by BIPM for metrology, that is the three subfields. One is scientific metrology, legal metrology, or industrial metrology. See, scientific metrology bears with all scientific development which concerns with the establishment of the unit of measurements, that is this international system of units, and they are established under the framework for the internationally accepted units of measurement called the international system of units. And there are, the international units, they are like the primary standards. You can see primary standard of temperature is realized by the triple point of water, where three phases of water all together can exist at such a temperature, which is defined as 273.16 Kelvin, and in degree C it is 0.01 degree C, with an accuracy within a CMC, the calibration and measurement capability of 1 millidegrees, that is 0.001. Such high precision measurements are governed by these base units. There are 7 base units which are defined by the fundamental units. You see the constants. Mass is now defined by Planck's constant, length by velocity of light, time by transition period, temperature by Boltzmann. Well, so these 7 base units are defined now precisely by fundamental constants, and their precision goes manifold. For example, here you can see the definition of kilogram, 1 kg, which was earlier defined by 1 kg of prototype, which was kept in BIPM France, and accordingly different copies were given to different countries. India has got copy number 57. But now, recently in 2019, the new definitions of these parameters came internationally, and they are defined by fundamental constants because of the high precision, and measurement accuracy goes manifold. Legal metrology is another branch of science which is used for the quality control of the measurements, and its workplace protects traders, consumers, public sectors for critical parameters for fair trade. So OIML is the International Organizations on Legal Metrology, which is the international body, and in India, the departments of weights and measures, or the legal metrology departments, takes care for such measurements. For example, recently the mercury thermometer was discontinued, and in place the digital thermometers was used, and this is controlled by legal department of India. Then industrial metrology is again where measurements are very important for developing and producing and manufacturing very precise instruments, and they are used everywhere, whether in the laboratories, whether in the public sectors, whether in these industries. And what is important, the accuracy and precision is very, very important parameters for such instruments. And the international organization, the BIPM, is the body which is responsible for controlling these units of measurements. So in 20th May 1875, the Meter Convention was signed, and under this BIPM, the CIPM, the International Committees on Weights and Measures, have different organizations for maintaining these units under the committees, and these committees are for every parameter different committee is formulated. For example, CCM is Consultative Committee on Mass, CCT, Consultative Committee on Temperature, and like that, all parameters were internationally defined. And a mutual recognition arrangement, RMA, was signed by all countries with BIPM so that uniformity of measurement system could be adopted in each nation. And these are the National Metrology Institutes, which are the organizations responsible for maintaining these standards, these physical units, and then disseminating to their other departments in the country for the development of the country. So NPL UK, NIST USA, NRC Canada, KRIS Korea, NPL India, NMIJ Japan, PTB Germany, and a large number of national metrology institutes, around 130 countries who have signed the meter convention for adopting the units in their country, and that's why uniformity of measurement system is adopted throughout the world. National Physical Laboratory, CSIR National Physical Laboratory is designated as the National Metrology Institute for India. It is the custodian of national standards of physical measurements by the Act of Parliament. All physical measurements in the country are traceable to the standards. They are maintained by NPL by comparison directly or indirectly through unbroken chain of calibration by accredited laboratories as per international standard ISO IC 17025-2017, which is the current standard, assessed by National Accreditation Board, NABL. So how the calibration is important? Why calibration is important? You can understand by this picture. You see, in 2020, a COVID came, and this pandemic has a very severe effect on the human beings, and you cannot touch a person who is affected. So there was a need to measure the enhanced temperature of the person from a distance away. So infrared thermometers was
Dr.
the
Singh,
only device
Dr.
which
Singh,
was used for the calibration,
Dr. Singh,
for the measurement.
may I request you to kindly conclude your talk, please?
Yes, sir.
May I request you to kindly conclude your talk within 2 minutes?
Okay. So these, these thermometers were used for the only measurements to differentiate the people who are affected. So what is calibration? Is basically the comparison of any device with the master, and you have so many devices in the industry. And what is done in the calibration? Basically evaluation of errors and uncertainty of measurements. So now coming to why calibration is important in food and oil industries, you can see that the food safety is a key topic of concern among consumers, and the future of food safety starts with testing and calibration of the instrument used in the food industry. I give a simple example, the pasteurization, which is where the milk is heated at a certain temperature, and that temperature is very accurately measured. And the volume and pressure is to be monitored. And why this is done? This is done just to remove or to kill all harmful microbes or bacteria which are available in the milk. So this is how the calibration is important in the food industry or any industry where the accuracy of measurement is required. In GCMS, you must be knowing that this is very, very precise instrument, precise equipment for the detection of the trace elements in the sample, and the calibration of this device is also very important, which is external calibration or internal calibrations. Without this, you cannot find out the accurate detection of the trace element. And the improved precision and reproducibility of result is also important. So the factors affecting calibrations are their quality, purity, accuracy, stability, linearity, sensitivity, and so on and so forth, because the reference, the material, reference standard materials are used as a standard against the certified reference materials are used, which are calibrated against the reference standard materials, and in this way, the standards of used for the detection in the GC. So although there are so many parameters, the calibration of calibration frequency of GC, and they are very, very important parameters when you are required to recalibrate the GC for the purpose of accurate measurements. So if any drift or deviation or troubleshooting or regular intervals or performance of the GC, or it is required by any regulatory or quality requirements, so then you require the calibration. And again, calibration's verification is also there. Once you have done calibration, but then again you have to verify. And the verification is just for the known standard where the value is lying within the expected value, and if the expected value is lying within the acceptable range, then only the GC is working well, otherwise you have to go for recalibrations. Then important calibration in the food equipment, you can see that there are various requirements, and the calibration is required for the manufacturing as well as for the important equipment which are used for the manufacture. How does metrology support the trade? There are various components where the consumer protection is there, and I just give an example that as per data, recent data, a measurement error of just 1% in the amount of natural gas consumed by the whole world in a year results in economic losses of billions of dollars. And that is, you can imagine that 1% is very small amount, but how much are the losses if your equipments are not delivering the accurate results. Similarly, dispensers in the petrol pumps, also you can have the losses for a large sum of rupees. So you have the consumer protection by metrology, reducing the technical barriers to trade. This is very important in this topic because your certificates have to be accepted by the other nations if you are exporting your goods. And that's why this technical barriers to trade is only governed by the metrological treaty among the countries. Facilitating global trade, control of fraud. If it is any fraud is going, metrology will come to evidence the rectification of frauds, reducing the disputation and transaction costs, full benefits to the commodity of export. So these are the various important topics where metrology support the whole industry. Now, metrology at Fair Labs, I just want to say a few words about Fair Labs. That Fair Lab is one of the premier laboratory in food industry, no doubt, but it has also established the calibration facilities in the metrological areas and accredited as per 17025-2017 standards in the area of thermal, mechanical, dimension, flow, electrotechnical, and many components are there. Particularly in thermal, the facilities goes from minus 200 degrees to 3000 degrees, and all sorts of instruments which are used in the industry are calibrated at Fair Labs. And primary standards are also are maintained, which is establishing the facilities next to the National Physical Laboratory. Also, there is proficiency testing provider. It is already, given information by Dr. Raja that this laboratory is also a PT provider in both testing and calibration area. So ultimately, what I wish to conclude that measurement standards are very, very important in food industries or any industries. So we have to follow the national measurement standards keep all measurements consistent, repeatable, independent, and solve the problems of infinite regrets, that is the differences between one lab to other in the calibration and metrology. So we have to follow one nation, one standard. Thank you.
For a very nice talk on elements of maintaining quality standard in food and oil industry. Now, may I request Mr. Vijender Singh, scientist E, BIS New Delhi, to talk on oleochemical standards for assuring sustainability, quality, and international market readiness. Thank you.
नमस्कार, गुड आफ्टरनून। मैं अपने आप को बहुत ब्रीफ रखना चाहूँगा। सुबह से ही हम ओलियो केमिकल्स, ओलियो शीट्स की बात कर रहे हैं और बहुत कुछ हमने सीख लिया है, बहुत कुछ हम अपने बैग्स में कैरी करके लेकर आ रहे हैं अपनी नॉलेज। So I will take only 10 minutes, but in that 10 minutes, I need your undivided attention, because I know you are tired, because you have gained a lot of knowledge and information, and it takes time to digest, because you just had a lunch also. So I am just taking 10 minutes, and my presentation will be shared with you later on. I will not share my presentation. For that I seek your apology. Because I think it would be good if presentation is running, you see there and you think, okay, I will read it and that. So I just need your attention. So I start from where Mr. Lal has ended. He mentioned that it is the time to think on whether we want to be a standard maker or a standard taker. Why? He concluded that because internationally standards are being made. Even if you are taking your time to think on whether I need to make a standard on that product or not, standards are being made and they are being written. And if you are not taking part in that, you are surely going to take that. You have to follow that. So it is the important time to decide whether you want to be a standard taker or maker. And when we talk about what is the standard, because in the morning also we heard standards, in the afternoon also we talk about standards. So I just want to make it a little bit clear that standards are nothing. They are voluntary in nature. First thing we have to understand, standards are not mandatory unless they are forced by some rules, some regulations by the government. So it is always beneficial that if you are taking in the voluntary process, because at that time you can raise your voice, you can make your point that okay, the thing should be in such a way or not. So it is very important that we take part in that voluntary process. Oleochemical is also one of the important area. We have heard a lot of things, and BIS is also taking care of the oleochemicals, oleo sheets and other things. I can tell you at least there are 8 technical committees. 8 technical committees, those are working in the field of oleo sheets, oleochemicals, be it cosmetic, be it detergents, be it lubricants, be it biodiesel. So there are at least 8 technical committees, those are working in this area. And I'm proud to say that we have made at least 500 standard directly or indirectly related to oleochemicals. Again, I would like to make a point. You all would be aware, because I see a lot of familiar faces in this hall, because they are participating and contributing the standard making. These standards, very rarely they define that what should be the raw material. So if there is a material mentioned, the product quality has been specified. You take it from petroleum product or you take it from the oil. It is up to you, because ultimately you have to meet the final quality of the product. So the oleochemicals, when they are growing fastly, they have a lot of space. they have a lot of potential to fill in. As I mentioned, we have a lot of standard in that, but still there are gaps. And as a player, whether you are the academician, or you are the manufacturer, or you are the testing lab, or whoever you are going to use that standard. And if you find any gap, you should come forward, you should tell that, because the developed world, what they have done differently is that they took the participation in the standard making. They led the standardization process so they could be in the advanced stage. So this is up to us that we decide or not. Then when we are mentioning, I am mentioning that we are making standard in at least 8 committees. I would also like to say that it is not only at the national level, at the international level also, we are equally contributing on that subjects. And again, I am proud to say that some of the members are sitting here, those have shown their zeal, they have shown their interest, they have taken the lead. And at least we are going to lead 4 projects at the ISO level, those are soaps and detergents level. So this also shows that what is the commitment. So similarly, if more people are coming, because there is no lack of knowledge, there are brilliant people, brilliant minds are sitting. There are different people, those are doing exceptional work in their field. Only thing we have to come forward and take participation in that field. Why I am saying all these things, why I am asking you to participate is that, because one thing is that, because the standards are being made. The other thing is that, we all know there are a lot of push at the national and international level. Recently we have seen that US new president there, he have put again tariffs in the mind, and the tariffs are going to play some role for some time. But there also is still technical regulations are there, and the world is moving very fast with the technical regulations. And the number of technical regulations coming every year is tremendous. I have a figure I would have liked to show you, but I just want to say that I could see that there are 1,200 technical regulation worldwide. Those refer to fatty acids, only fatty acids. Oleochemical is not only the fatty acids, I believe, you know far. So there are 1,200 technical regulation concerning to fatty acids only. And India, as of now, to my knowledge, if someone can correct me, we have hardly brought out some 10 products under the mandatory certification relating to the fatty acids, hardly. So we can see what is the gap, how much product, how much the Indian market is still to evolve. And see, till we are sitting here and we are thinking about our business and we are not participating in that activity, I would also like to remind you, if you will see the government chart of last 5 to 10 years. 10 years back in India, there were technical regulations that were for around 121 products. Now the number has gone to around approx 700 products. So the government is also regularly reviewing and bringing the new regulations. So today or tomorrow, your product may also be under the ambit of the technical regulations. I'm just giving you a hint. I'm not warning you, because you all are learner people, you know what is good for you or not. But this may be the interest of the manufacturer or industry. But the academician also have to play a crucial role. The R&D centers also. Because what happened that the industry keeps always their economic or other benefits in mind. They sometimes compromise with the sustainability and related issues. So we need academician, we need experts, those can come forward, they can talk about the sustainability aspects. They can help us to bring more relevant standards, though BIS has developed some standards. We have some good practices for the manufacturing of oleochemicals and for their handling and other things. But as the time is evolving, every day new innovations are coming, new products are coming. How to deal with this product? It is a challenge. And for that, standards are going to play a crucial role. And the standards quality will depend how actively we are participating. We can criticize that, okay, the road quality is not good, the standard of soap is not good, the detergents are available in the market, it's not good. But we should keep that in mind that we are also equally responsible for that. Because I am as a manufacturer, I am as a professor, I am as technical person, if I am not contributing, then I am simply blaming others. So it is the request, it is the need of the hour to think on that part. And while this may sound very much not of interest to the students, but my say is that because tomorrow you are also going to be in the field, maybe in the industry, maybe in the R&D center or wherever you are going to, keep in mind standard is always going to be on your front side. And I believe I will conclude with my last one question only. How many of you are having a smartphone with you? How many of you? So still some people are sleeping, not an issue. But if you have noticed, your smartphone on the back side, it is having a mark, which is a ISI mark, which shows that it is the quality of the product. So every stage of your life, this is not related to oleochemical, but every stage of your life you are encountered with these standards. So this is the impact of the standard that you are going to see in the near future. My sincere apology that I didn't show my presentation, because I thought I need your undivided attention so that we can just think on that, the need of and importance of these standards. Thank you very much.
Thank you for a wonderful talk.
The next speaker is Mr. Sudipta Ghosh Dastidar, Technology Leader, Personal Care and New Product Development, Unilever. His topic of presentation is Designing for Sustainability, Material Efficient Soap Bar Material Efficiency in Skin Cleansing Bars and Liquids. I now invite Dr. Sudipta Ghosh Dastidar to share his thoughts.
Thank you, Chair and Co-Chair. First of all, I want to take this opportunity to thank the organizers for giving me this opportunity to present in this forum. The topic for today's discussion is Designing for Sustainability and Material Efficient Soap Bars. Now, as we all know here, being oil technologists, that by soap, what we mean is that sodium potassium salts of fatty acid. And the way they are prepared is that they are prepared by reaction with caustic to give you glycerin and soap. Now this is a reaction which has been old. This is as old as 2500 BC, where the first known manufacture of soap was tabulated in Babylonian texts, so in Babylonian tablets. So that is how old this technology is. Now you have to realize that if you have to make an innovation in this field, and especially if it is a sustainable innovation, you have to be extremely creative, because this has been there since ages. Now, when we talk about soap, about 70 to 80% of soap is oil, and this is a theme which I will keep on coming to it in this presentation. Now, soap, what soap does is that when soap reacts with water, rather is solubilized in water, it can form variety of hierarchical structures, and this is well known and reported in literature that when you have a very dilute solution of soap, you can get to a spherical or a worm-like micelles. Now, if you increase the concentration of a bit more, what you get to is the liquid crystal domain. So you get to a cubic crystal or a lamellar crystal or a hexagonal crystals. And this is before the LED TVs and the smartphones made liquid crystal popular. Liquid crystal was already existing in soaps. And then if you further increase the concentration of soap, you get to the ribbon-like structures and the soap crystals. Now here I want to mention that when we talk about soaps, there are two kinds of soaps: the insoluble soaps, which is the long chain soaps, and the soluble soaps, which is the short chain soaps. So this soap, what we have is that the primary source of the oil of the soap is palm, and that is the reason why we need palm to produce soaps. The way we define a soap is in terms of a brick and mortar structure. So what we mean by brick and mortar structure? So the insoluble part of the soap is actually called as the brick, and this is the part which actually give you the structure to the soap. Now you have to realize that this has no other function but just to give you a structure to the soap, and when you wash your bathing bar or a soap, it goes down the drain. So that is a wasteful wastage of palm which you are doing by putting more and more bricks in the soap. And the actual function of the soap is done by the mortar part of the soap, that's why we call it to be brick and mortar structure, like as you will get in a stone wall. So the mortar part of the soap constitutes the soluble part of the soap, where you will get all your sensories starting from lather to cleansing action, etc. Now there is the SCM micrograph shows how a brick and mortar structure actually looks in a soap. Now in India, primarily the soap is manufactured from palm oil, and in other parts of the world, tallow is also used, which is not permitted in India. Now in this chart, I want to introduce one term called TFM, which is total fatty matter. So the total fatty matter actually signifies the amount of oils you are utilizing in a soap. And as I mentioned earlier, that more than 70% of a soap is actually oils. So the TFM of a soap corresponds to about a 70 TFM for a traditional soap. Now, as we are utilizing palm in the soap, what is the sustainable and environmental impact of palm? Now, when we are utilizing palm, we are actually utilizing the rainforest of Indonesia and Malaysia, and we are going to a deforestation in that zone, in that region. And you can see that satellite image shows how the rainforest has degraded over time. And also, what we have seen is that there is an increased production of palm oil compared to other vegetable oils also. And that goes on increasing year after year, and it does cause problem to the environment in terms of water usage and the soil properties of it in the long term. So deforestation is a problem which when we are dealing with palm oil from that aspect. And this has been highlighted already in the morning, that we import most of our palm. So India as a country import about 90 lakh hectare, which is about 90 lakh ton of palm, which is about 9 million tons of palm which we import. And of that, a small fraction of it is used for making the cosmetic soaps, and the rest primarily goes into the edible oil consumption. So if you have to see that we are talking about circular economy and we are talking about saving for foreign currency here in terms of import, a ton of soap cost about $1,000. So if you can do a reduction of palm by about 20%, you are going to save a significant amount of foreign currency in terms of importing palm. And what we can do here, we can take the approach I was talking about, that the bricks forms the maximum structure of the bars. So if you can sort of reduce the bricks which is there in the bar and prevent the wasteful wastage of palm, you can have a significant sustainable solution. And in that, we have a twofold approach. First, to use sustainable oil, and here we are committed as a company, Unilever is committed as a company to use NDP certified oil. NDP stands for no deforestation, no peat, no exploitation palm, and we are going to 100% NDP certified palm oil in all our product usage. There are other sources of oil which one can use. There are other sustainable sources like Macuba oil, and Macuba is the oil which is used in Brazil. The advantage of Macuba oil over palm is that you can grow it on wasteland, and the water requirement of this plant is also very less, and you can have a better yielding variety of this plant also. The other approach, and I will talk about this in subsequent two charts, where we can use biotech oil like algal oil as a substitute to palm. In terms of a formulation-based approach, what we can do is that I already explained the structure of a soap being a brick and mortar structure. So what we can do is that we can engineer bricks in a sustainable way such that we have less bricks in the system. We can also think about using alternative bricks which are sustainable, and also another approach which we can take is by incorporating more water in the soap bar. So essentially, if you have more water in the soap bar, you can structure the soap bar essentially well, and by that way you can also think about reducing palm. Now I spoke about algal oil. So algal oil, as the name suggests, is produced by algae, a microorganism, through the regular fermentation process. And what the advantage of this oil is that it can have various cuts of fatty acid which is not prevalent in usually which is not found in nature. So you can actually re-engineer your oil, and this is not certified as GMO because you are separating most of the oils during the filtration process. So this microalgae grows into, so the process actually takes about 10 to 15 days to get fully formed. So you can actually put wasteful products from your agriculture resources and in a bioreactor, and you can have algae sort of grow onto it, and from that the algal oil you can actually then produce a soap. So this is one approach which we are also sort of looking at. The next approach which I talk about is reduction of brick, which is the formulation based approach, where one can think about using alternate sustainable bricks, and one can think about using more water structuring in the soap bar. And that what we can do is that what we are trying to achieve is by a mix of biopolymer, inorganic polymer and water, and this essentially sort of forms the core structuring of the soap bars, which then sort of helps us in reducing the bricks which is coming from palm. And by that we can actually go to about 50% reduction of palm oil. But however, it is not easy. There are constraints, and primarily what you can call as soaps comes from a regulatory constraints which various countries sort of have. But if you look in most of the developed countries, there is no standard of soap, and mostly they are voluntary in nature. And this sort of encourages actually putting in new technologies. But in India and in South Asia, there are standards. We call it to be grade 1, grade 2, grade 3 soaps, and there are various TFM, the total fatty matter, which is associated with these soaps. The point I want to make is that, and as I will show in subsequent chart, that grade is actually not equivalent to a quality of the soap, which essentially means a higher TFM soap doesn't actually says that it is a good soap. You can have TFM which is lower and still give functional superiority to the consumers. So this is one of the data where you are comparing a low TFM soap, a TFM as low as 45 and 30, and where we are comparing the lather to be similar to that of a high TFM, which is a 70 TFM soap. We are comparing the cleansing efficacy, where the lower TFM soaps are actually similar to that of the cleansing efficiency of a high TFM soap. So lather and cleansing efficiency is not compromised when you are doing a low TFM soap. Similarly, in some of the soaps we require antimicrobial efficacy. So the antimicrobial efficacy of the soap is also not compromised when you are going to a lower TFM soap. And also one of the important aspect, the mildness part of the soap is also increased because you are having lesser soap in the system, which would essentially mean that you are having lesser soap to solubilize your zyme and lipid and protein in the system, and which would mean that you are having a milder soap. So lower TFM soap actually signifies a milder soap. Now we are doing this for sustainability, and as the figures suggest that as you go lower and lower in TFM, you are actually producing more and more sustainable soap. So we are doing a sustainable reduction in greenhouse emission to almost close to 50% GHG reduction, so which is a huge savings. Now, saying all this, this is not possible if we do not work closely, if the industry, academia, and the government work closely to get to this kind of standards. So as an industry, we can come up with new technologies, but the validation has to come from academia, where the new scientific insights has to come. And then we have to work closely with the government agencies to educate our consumers in terms of the newer sustainable innovations, and which then we can keep it as a standard. So summarizing my talk, what I can say is that sustainability is an opportunity to drive new innovation, as you have seen in the example of soap bars. The regulatory standards needs to evolve, and we have to work with the regulators so that we can promote sustainable innovations. The sustainable innovation has some of the data where I have shown the data on mildness and some of the data on lather and all, which shows that sustainable innovations indeed can provide product superiority and benefit to the consumers. And as I mentioned lastly, that we have to work together in this. The industry, academia, and the government has to work together in this to implement this to drive sustainable innovations. Thank you for your attention.
Thank you so much, Dr. Dastidar. The next speaker is now Mr. Atul Joshi, General Manager, Process Engineering, Desmet India Corporation Private Limited. Topic of his talk is Kaizen approach to upgradation of the existing vegetable oil refining plants. Now, over to Mr. Joshi.
There is a small interruption. There is a small interruption. The speakers have to go, so we are going to give them a memento before next lecture, please.
As a token of our appreciation and gratitude, we would now like to facilitate with a memento. I request Dr. R.P. Singh sir to kindly present the memento to Mr. Ajay Kumar Lal sir. Next, I request Dr. H.B. Singh sir to kindly present the memento to Mr. Birendra Singh sir. Next, I request Dr. H.B. Singh sir to kindly present the memento to Dr. Y.P. Singh sir is to be received by Mr. Sameer Singh sir.
Hello? Yeah, sorry. I thank you for this opportunity, and I specifically thank all the students who I see they have worked very hard to organize this. The topic is the Kaizen approach for upgradation of existing vegetable oil refining and oleochemical plants. So Kaizen is a approach of continuous improvement based on small ongoing positive changes, and this is just an attempt to compile some industrial proven measures which can retrofit in most existing refining and oleochemical plants and yield major advantages. These are the features which already exist in new plants. Why Kaizen? Because we have a large legacy of old plants. We have refinery and oleochemical plants supplied as early as 1990s, which are still in operation. Adapting Kaizen measures, okay, these we need not elaborate again, but they primarily focus on safety, yield, steam and power, which is sustainability, capacity, product quality and product versatility. Within oleochemicals, fatty acid complex, if we go to the fat splitting section, a typical Kaizen application will be in the economy of the steam. After the sweet water is separated in the splitting column, in the older plants we have a single stage pre-concentration section which yields only 12% sweet water. This can be replaced possibly with a triple stage multiple effect evaporator, and the multiple effect evaporator can increase the sweet water concentration to 25%, but also can save 200 kg per ton of steam per ton of feed, 200 kg of steam saving, which is not negligible. The next thing which can be highlighted in the old fat splitting sections is that many of these fat splitting sections are 30 bar sections, although this cannot be easily called as a Kaizen measure because it's a large investment, but still a transition from 30 bar gauge to 55 bar gauge fat splitting gives two advantages. First, we eliminate the thermic fluid hazard, and secondly, we can get a yield increase in the distilled fatty acids of around 2.5%. The pitch reduction is from 4.5 to 2% straight. Going to the distillation, we have the configuration of the normal distillation, fatty acid distillation plant is a pre-cut column, the total distillation column and the post stripper. The pre-cut column focuses to separate the light ends. Total distillation column separates light ends and heavy ends, and then it separates out the distilled fatty acids, which are primarily the product. The pitch is separated as the bottom impurity. We need to have for fractional distillation. Then it can be designed to separate 30